Okay, right now we're going to take a look at this question together. So in a 3DMQ vessel, the initial amount of nitrogen, oxygen, and nitrogen dioxide are 1.6, 0.81, and 0.18 mole respectively. So when the equilibrium is reached, right, the amount of nitrogen is 1.55, calculate the value of Kc. So this is the equation. Now, normally the first step is to write down the Kc expression. So what do we do? Very simple. I write down Kc. Now, first of all, we see, is there any water in the reactant? No, so that means that we need to factor in everything present in the reactions. So I write Kc. Remember, C represent your concentration. So that means that you use the product, always put a square bracket, NO2 to the power of 2, because see, there's a 2 here. Then you divide by your N2. Then you times O2 to the power of 2. So this is how you write your Kc expression. Then after which, what we're going to do is that we're going to use the ICE table to find the concentration of the reactants and the products at equilibrium. Very simple, we fill in the blank of what is given. They tell us that, right, the nitrogen inside got 1.6. So I put 1.60. Your oxygen is 0.81. Your nitrogen, right, dioxide is 0.18. So this is actually, right, the number of moles for all these gases. After that, they tell me that at equilibrium is this one. Your nitrogen is 1.55. So that means that, oh, nitrogen is 1.55. So I put 1.55 here. And that's the only information I have. Then with this in mind, I need to solve and fill in the rest of the blank of the ICE table. So what I'm going to do, very simple, I will observe what's the difference, right, between, right, this to this. You realize that the difference is actually minus 0.05. Now do remember, your N2 and your O2 is the reactant. That means that the reactant actually involved in the reactions. Hence, right, if this one is subtracted by 0.05, do you realize that this is actually a 1:2 ratio? Hence, you need to use 2 times 0.05, and you must put a minus here because reactant decreases. Then don't forget, this is also 1:2 ratio, but this is a product, so you must plus 2 times 0.05. Then after which, you can do the calculation to find out the value, right, of your O2 and NO2 left over. So from here, right, based on the calculation, I get this as 0.71. This one will be about 0.28. Which means that after I find out all my ICE table finished already, I go to step number 3. Step number 3, I need to find out, right, your Kc value. Now, very importantly, you need to trace back, hey, what is my volume of the reaction? The volume of the reaction here is stated is actually 3dm³. So I'm going to go down. That means that the volume is 3dm³. I rewrite the Kc expression again. This is actually your NO2 square. Remember, it's a square bracket, then divided by N2. Then you times O2 square. I simply substitute in the value. Now your product here is actually 0.28, but do you keep in mind, these are all in mole, they are not concentration. Divide by 3, then you square it. Divided by this one, N2 is actually 1.55 divided by 3. Then you times oxygen gas is 0.71 divided by 3. And after that, you put a square here. So after that, you should be able to get the answer. Okay, after you do the calculation, right, you should be able to get the value at 0.30101. But you see, right, this is only, right, the values. You need to find out the units. So how do we find the units? Now, for those students, right, who actually, right, learn, right, physics before, you can know the unit conversion very easily. But for those of you who are not sure, let me show you exactly how we do it. So for now, right, we will treat this as a mathematical equation. What do I mean? Very simple. Kc units is equals to concentration, the unit is mole per dm³. Then you square it because you will tally to the square here. And I repeat the same procedure for the rest. So this is mole per dm³. And this one is mole per dm³ square. Then after that, you realize that these two can cancel off, and you can actually bring this up to the numerator. You will get mole to the power of -1 dm³. And this will be your unit. So which means this one approximately 0.301 mole to the power of -1 dm³. And that's the answer. And do remember to try the checkpoint on the next page before you check the solution subsequently. Okay, remember to pause the video before you proceed.